camera 1, camera 2, camera 1 and 2, camera 1, 2, 1, 2, that one, this one, with all the cameras. Look, we made a thing and it goes through the cameras. How cool is this thing? Look at it, I'm pushing buttons. Welcome back everybody to Sorted IT's Workbench buildy bloggy thing. Basically this is a step-by-step, not so much tutorial, but just video diary of the things that I'm going through and building for the Workbench to bring you the videos that you see here. So last video we did our lighting, as you can see. My hands are very bright, lit up, nice. You can probably hear that we still have to work on the audio. That will be the next step. But for today, I wanted to work on some camera stuff. So at the moment, you're looking at me through the C922 Logitech webcam. It's a 1080p webcam. It's what I'm using for my overhead. I also have, which is sort of a camera, sort of not, my digital microscope, which has a HDMI out. At the moment, I'm not using that just yet because I have some other things to set up for that. But what we do need is a better way to cut between the overhead camera and the microscope on the fly, because I don't want to do any editing. I'm just using OBS software, and it has this built in. It has this thing called hotkeys where you can set up a keyboard and say, just for example, you hit the number 1 and it goes to your number 1 camera here. Hit number 2, it goes to number 2. And you can do really cool things, like you can set up a scene with, say, the overhead camera in as the main large photo or picture, and then down in the little bottom left hand corner or wherever you want to put it, you can have the other camera. Now this is going to be really helpful when I'm working on microscope stuff, because the close-up macro shots, yes, they give you a really good view of the circuit board, like the part that you're actually trying to work on, but you kind of lose your bearings as to where you are overall on the job. So, you know, you'll be zoomed in. Am I down at the bottom left? Am I at the top? Where am I? So that's where the picture-in-picture will come in handy. The problem is that my streaming computer is actually about 3 laptops all cobbled together, which is then hot glued, duct taped and screwed to the wall. Not the easiest thing to get to change scenes as I want. So I could just use a normal keyboard, but using a keyboard is going to do a few things that I don't really want it to do. So for one, it's going to take up a massive amount of space on my very cluttered workbench already. I honestly just don't have space for it at all. Even a miniature keyboard would just be too much, and realistically I'm only going to use about 4 buttons. So that's where the super duper cut to the other camera thingy magic box of awesome 3000 comes in, trademarked. So basically what this is going to be is, inside of a keyboard there's a control circuit board. We're going to pull one of those out and then wire up our own buttons. Put it into a little box that can be screwed to the edge of the bench or somewhere, I'm not sure, maybe mounted to the wall, we'll figure it out. And that way I can just hit overhead cam, cut, and it'll go straight to the next one, and I can queue up what I want the next one to look like. So for example, I can have something underneath the microscope and see what it looks like, make sure it's all in focus, and then cut to it. I may, depending on how much space I have left on the actual physical box itself, because it is quite small, it's only about this big, I may put on a couple of buttons there to say stop recording, start recording, mute the audio. I don't know if I'm going to do that just yet, because I really don't want to accidentally stop the recording and then keep working, and if it's mounted to the bench it might, yeah, it's not really something I want to play around with. So we'll get rid of that and we will get our donor keyboard. This is a, I don't know, $9 keyboard, I think it was under 10 bucks. That is about all the unboxing you get, because that's all that's in the box. We've got our standard, very cheap keyboard with a USB cable on it, which is quite long, which is exactly what we wanted. We don't want to have to lengthen it. If anything, I might actually shorten this cable, because it may just sort of run along the wall and down next to a monitor that I have here. Okay, so I guess the very first thing we should do is void the warranty straight away and pull it apart. So as we can see, well, that's interesting. Looks like they use the exact same case for their wireless keyboards. There's a battery compartment that's not punched out of the plastic. Anyway, so it looks like it's using very bog standard Phillips head screws. I think they're a Phillips too. So we're going to get our iFixit kit out, and we'll pop in a number 2. And normally I would want to keep every single one of these screws in the right order in the little map thing that I've got to the side here, but we're never going to put this keyboard back together again. So let's just pull it apart. This is an obscene amount of screws for a very cheap keyboard. Screws cost money, which is odd for a cheap manufacturer to do this. Normally they just either press fit them together or glue them together even. Anyway, we'll go right around the edge. I think I missed one there. Might just get that microscope a bit further out of shot. Where were we there? It says keep going around, keep going around. How many screws do you genuinely need to hold this thing together? That's ridiculous. This is poor engineering. There we go. On the plus side, it means that we can get into it a lot quicker. Okay, magnet. Got a screw that doesn't want to come out. That's alright. I'll just work around it. I could honestly cut this case open with a hacksaw and it would still serve its purpose. One more here. Nope, the top ones just don't want to come out, but that's fine, because there we go. So this is what is inside of your keyboard. So we've got like a mesh membrane, basically. And this membrane, it's actually 2 layers. Oh, 3 layers. Oh, we've got a separating layer. And what this does is when you press a key, it bridges the gap in the circuit. It's just a switch. They're just a series of switches. We don't care about any of this. All we want is what's up here. So we'll pull that one out. If we're lucky, this might not even be a soldered in membrane. This may just be held down by this plate. I've never pulled one of this brand keyboard apart before. Have used this a lot in arcade machines way back in the day, before keyboard encoders were a thing. So there we go. That is what we are actually after. And what we're going to do is run a whole bunch of wires off of these and figure out which ones we need to close in order to make a keystroke happen. So there's a few ways we can do it. The first one is we can just look at the circuit and see what key is going to which line in the matrix. I'm not talking about that awesome movie from the 90s, I'm talking about the grid of circuitry that is here. This is what we call a matrix, because basically what this does is we've got one line of circuits going one way, and then when you flip it back you've got another line of circuits going the other way. So we can trace every one of these back and figure out which key was which from that, or we can just run a whole bunch of wires off it, work out which one is the ground, and just start like tapping wires together until we get some keystrokes happening. I think we're going to do that one. Now, to get to the actual circuit itself, we may, because we're not going to be able to solder to this, these are carbon coated pads, we may have to actually scratch some of that back. I'm just going to get rid of this because it's reflecting pretty badly. So I've already got a whole bunch of rubbish which I might just clear off the bench. Okay, so here's our USB cable coming in, and here is the circuit that we want to have a play around with. Now unfortunately I can't really zoom in on it yet because we can't switch over to our microscope at the moment. That's what this whole video is about. So you'll just have to bear with me while I have a little bit of a poke around at it and work out what is what. We might even just cut the video here, and I'll come back when I've got a few pads stripped back and a few wires connected. We'll move on to the next step. Alright, so we've removed our USB keyboard matrix controller. That's what this thing is. And we're going back to the actual matrix itself that's found inside of the keyboard. Now what we've done, I'll just carefully flip this over, is we've figured out which is our first number button, so button 1, which is right here, 2, 3, 4, etc. Now we really only want to use these buttons here, and maybe even the next one across, because we only have 5 buttons that we eventually want to use in our final design. Now what we need to do is painstakingly trace these back and figure out which pins on the controller get crossed when you press the key. And then we can replace that with some wires and a button. So we'll start with number 1. So number 1 starts up here, and I'll try and trace it with this. I'm not sure if you're going to be able to see this because of the reflections. Unfortunately, we're working on a very, very, very reflective circuit surface. So 1 is here, and it's basically like one of those maze games. So I'm just going to follow it around. So what continuity testing does is, when the circuit completes, the thing beeps. So let's just find our first pad. So we're doing the bottom layer first, and we'll hold that one down with one hand onto the pad, and we'll start working along here. Hopefully we'll get a beep out of it. No. Awesome. So that does not conduct in the way that we want it to conduct. So lucky us, we get to do this by eye. There's one more test. Nope, absolutely nothing. Okay. Well, we might separate this. Very carefully, because we don't want to tear it, because we might get lost while trying to find our way through the circuit. Okay. So we'll get rid of our multimeter altogether because it is useless for this job. And there's our pin. So that one there is our first pin for number 1. So what we're going to do is we'll get a piece of paper and a pen. Now this is our bottom layer. So we'll call this B, and we'll call that pin 1, that pin 13. So for button 1, call that button, and then we'll call this bottom, and this one top, which will be the top layer. So for the bottom layer for button 1, we want pin 1. Alright. Now for button 2, looks like it's going to be very, very similar. And I dare say what will happen is it'll end up being the very next one across. That's sort of how keyboards work. It depends on the manufacturer as to whether or not they've actually followed like standards to everything. And if that tracks, that means that the pin for number 2 should be there. So there's another one that we've gotten worked out. So button 2 is bottom layer 2, if we're counting from this edge here on the circuit. Button 3, yeah, button 3 just seems to push us up one. So once again, you can sort of see where we're going with this. We're only one circuit up here, which means we're most likely going to remain only one circuit up all the way to the end. So we can take an educated guess and say that button 3 is going to be on the bottom layer, the third pin across. The fourth is going to be a little bit different because you can see they've already put one in between us here, which ends there. So that means we're the fourth pin across. Simple enough. I'm going to take a really educated guess and say that the fifth pin is also, sorry, that number 5 is also the fifth pin. Which could be dangerous. No, I reckon that we're going to be good there. So we'll say number 5 is that. Now we're going to find the top layer. I dare say, because we've got way fewer pins here, so there's the size of our connector for the bottom matrix, or the bottom layer of the matrix. There's the size of our connector for the top layer. Top layer's only got 8 pins, and this one should be a lot easier to trace. So here's our number 1 here that we tore the pad off of. So let's flip it over and move this bottom layer out of the way, or bottom 2 layers I should say. Keep our piece of paper handy. So that's number 1. Now notice that 1, 2, 3 and 4 are all on the same line, which is a really good sign. And 5. Wait, no. Actually, we'll start with number 1. Because number 1 will knock out 1 through 4, and then 5 will be a different pin. So and now it's that pin there. So that happy little pin, you know, we'll call this one our top layer. This is actually going to be on this side of things. So where's my pen? There's my pen. So we'll say, here's our top layer, and we've got 1, 2, 3, 4, 5, 6, 7, 8. So we'll call that pin 8, that pin 1. So for buttons, which ones were we looking at again? for buttons 1, 2, 3, and 4, they're all definitely on the same line. Button 5 is going to be a slightly different pin, which still comes up to here, and connect a pin. Well, that's technically 7 because I got it flipped over. So here we have, for buttons 1 through 4 is all pin 8 on our top layer, and number 5 is going to be pin 7. So there's our pin out done. That means that now we can get rid of majority of the keyboard, and luckily we're only going to have to connect 2 wires to this. Actually, we need those layers back again, because we need to see how these layers lined up. So that was on the keyboard like this. So we want one, 2, 3, and 5. So 1, 2, 3, and 5 across on this side. So here's pin 1. So we're starting from 1, which is going to be just there. When you flip it back over again, and you see how these lined up over these pins here. So that was pin 8 and 7. We flip it over, so that's pin 8 and that's pin 7. So if we quickly just trace around this, we got pin 1, we got 1, 2, 3, 4, 5, so 2, 3, 4, and 5. And then I realized that we're sort of counting from the other side, and we had it flipped, so it's all over the place. We'll call that pin 8 and that one pin 7. Okay, now we can get rid of those layers for realsies. Now we need to work out how we're going to solder to these, because these tabs here, I believe, these contacts that you'll see, that's terribly out of focus. There we go. It's also highly reflective. So the pins that are here, these black pins, they're actually made out of carbon. They're not copper. I have a feeling that there might be copper underneath the carbon. So we're going to try and scrape some of that away. Nope, just carbon. Yep. Okay, so we won't throw this underneath the microscope. I'll change how everything's set up. We'll go to the microscope and we will try and scrape back some of that solder mask and find somewhere to solder to. I might even just do it here. I don't think we're going to be able to actually show you on the camera just yet, because the thing that I'm missing for my camera is actually the HDMI splitter that lets one of the HDMI, or the single HDMI output that's just here, one side of it would go to the laptop and then the other side would go to a monitor that's right in front of me, because unfortunately with this microscope, what it does is it sends only the video to either the USB port, the HDMI port, or the screen that's built in that I am used to using to do all of this fine detail work. So unfortunately you guys miss out on this one. What I might even do is just cut the video here, and then when we come back I'll have the pads all set back and some wires attached, and we'll be able to continue the build. Alright, so we've scraped back the carbon on all of these pads. So it turned out there was actually copper underneath those pads, which is slightly unusual. Like, it's not unheard of, but kind of making a mess. Normally, what you would find under there is just carbon all the way to the circuit board, and there would only be a little bit of copper right at the very edge of that. But I was proven wrong. So now we're just going to try and tin these contacts. Now I'm using quite a large soldering iron tip for this job because we've got a lot of surface area. So I believe a smaller soldering iron tip probably wouldn't be able to get enough heat into it. And we have cleaned the circuit as best we can, like the scraped back part. But we may have to give it another go if the solder doesn't want to take, because the carbon is possibly built up a film of sorts. There we go. So everything's nicely tinned. A little bit messy, but that's what hacking stuff apart is sort of all about. Alright, so now we have somewhere to solder to. All that we need to do now is solder some wires on. I don't even think I'm going to really test it, because worst case scenario, it's just hitting our key. It may not be hitting the right key. And I did actually put one extra one on there that I'm just taking a stab at, saying that that's button 6. Just in case I want a spare button. For example, I am thinking about getting a third camera or a second actual camera to go with my scope that sort of sits here and has a much closer view of what's going on. I just don't know how I'm going to do that at the moment. So we'll work on that in the future. I'm going to cut the camera yet again and go and find some hookup wire and hook up some wires. See you in a sec. And we're back again. Managed to find some hookup wire. We're going to use some really nice ribbon cable. Now I've already trimmed the ends off, or stripped the ends off, and all we have to do now is just go ahead and tin all of these ends so that they stick. Now the way we're going to do this is use white and black for the top layer, so the right connectors, and then we'll use these other colors on the left, and we'll end up stripping this back as needed. So let's start connecting those on. We're still going to use that quite large soldering tip because these are quite large pads. We're not actually going to add any more solder, we're just going to use the solder that was already there. That should be fine. There we go. So now we have, instead of our keyboard, we've got some nice little hookup wire coming off that we're then going to run to our own buttons as needed. Now what I will do is just be super careful of this for now. I'm not really going to test anything. I'm going to connect it up to the buttons that we want to connect to, and then from there, then I'll test it once it's all together, because it's just going to be easier, nicer to, you know, see how it goes. Once that's all good to go, I'm just going to pop some hot glue down over the top of all these connections, and then they're never going to move again. So I'm going to cut away from the camera now, grab our project box, drill a few holes in it, and I'll come back when all that's done. So here's our project box that we're going to be using. It's got some nice little mounting holes on the side. This is all of about maybe $5 worth of component container, and we're going to be using these little momentary buttons that are just push to close, push to on is another way to say it. So we've got 5 that are black, and we've got 1 that's red. So here's our 5 scenes, and then here's our cut or our fade button, whatever you want to call it. So we're going to have to rule this out with a set square or a speed square, depending on what I have on hand, and a pencil, and just basically try and find our center line. We might divide this by thirds, I think, and then just try and evenly distribute these buttons along the inside. Now this is something that's going to take me quite a while, and I'm not going to make you sit through it. And I'll also run off and drill all of the holes away from this bench, because it is going to create quite a lot of swath, and I don't want to have to deal with that on my lovely tech bench. That's what my workbench is for. So just to give you a basic idea of how I'm going to be measuring this out, I'm actually going to be measuring on the inside, because as you can see, there's some bits that you've got to watch out for when you're going to be mounting components on these. They may end up getting mounted quite close together also. So we'll see how all of that works out, and we'll go from there with our red button just there. Alrighty. It's about an hour later because I've had a few customers in. Here is our new button panel. So I've offset some of them just slightly because it's going to be off to the side, and I don't know, it just seemed like the thing to do. So I've got these sort of in like a easier to more tactile, I don't know. And then a big old red button, and that's going to act as the change to the next scene. So what happens is, say we're on scene 1, you queue up scene 2, and then at the time that you want to change, you hit the red button. On the back of here is a whole bunch of terminals, so we're going to throw some solder onto them, and then we have our USB keyboard matrix control board. It's a mouthful, and I've already stripped off all the wires there. We're going to give those a quick twist and tin, and then we'll get all of it connected up, and we'll give it a really quick test, and then hopefully by the time all of that happens, it's all working. If it's not, we're going to go back, we'll figure out what's wrong, and we'll fix it, because that is what we do. We fix things normally and burn our fingers. That is a very important part of the process. So I'm very excited to get this side of it working, because then all that's left is my audio, because I'm sure you've noticed all of my videos so far have terrible audio, but that's okay. These aren't exactly wasted episodes, like they're not filler, because it is, you know, sort of teaching me what not to do. Speaking of what not to do, always be mindful of where this part of your soldering iron is sitting, because yeah, you could lean it down on something that's quite important while you're trying to get to other components. This is why it's generally good practice to remove whatever you can from a device before you start poking around with a soldering iron. Okay, so all of our buttons are nicely tinned up now. Got a little bit of solder on them. They'll be much easier to connect to. Now we just need to pop that soldering iron away and finish off our wires over here. So we've already stripped the ends, we're just going to give them a bit of a twist. I find with fine wires, if you can afford the cable length, strip off a little bit extra, and it sort of gives you something to hang on to. And then after you tin it, you can trim them back as needed. Now what we're going to do is, you could consider most of these your signal wire, and then these your ground. To be brutally honest, I don't exactly fully grasp how a matrix works. I'm not going to sit here and geek all that out to you. I just know how to use them, which in my opinion is sometimes more important, because you can know everything there is about a car and still not know how to drive it. Whereas the majority of us are just happy knowing how to drive the damn thing, and we don't need to know the ins and outs of internal combustion. Same principle. Alright, so they're all nicely twisted up. We'll sort of splay those out so we've got something to work with. Yep. And hit all of these with a soldering iron. Now, being really thin wire, you do have to be pretty quick with the iron. If you don't get it the first time, give it a quick pause, come back to it, because otherwise what you'll find will happen is you'll start melting the insulation back, and then the insulation will get mixed, the melted insulation will get mixed with your solder, and then nothing will want to stick to anything else. There we go. So we'll trim all of these off with, I don't have my side trimmers, so we'll just use scissors. Good thing about ribbon cable is you can just line it up and just bam, done. Okay. So, what do we got here? We got 5, 6. So this is basically just pick one side. So in my case, I'm going to do the furthest side. And we're just going to make sure that each one of these buttons just gets one of these signal wires. I think what we might do is pick one. Actually, we'll use the end one to just hang back a little bit, and that'll go to there. So we're going to go up the top first. There we go. So that's all of our signals but one. I'm just going to pop that back there for a sec. Just gently massage these out of the way so that we can continue soldering. We're not at the pretty part yet, we're just at the part where we're trying to make sure that everything works. We're going to make this beautiful by the end. Okay. Now we've got to put our ground on. Now this is the part where you really need to go back and double check this. I'm kind of lucky that basically everything but number 5 and I believe 6, because that was the other one that was a bit different. Everything from, so 1 to 4 is going to use the top layer 8, which is our black wire, and then everything else will use our white wire. Now we know that this side was our first number and we worked out that way. So the two that are going to have the white wire will be the purple and the grey, which are these two, and the ones that will have the black wire will be these ones here. And there's a little bit of a trick that I'm going to do on this. So instead of running 5 wires off of that black, we're just going to use the one, and we're going to strip back part of the insulation, join in, and then the rest of this will just be one bare piece of wire, which is fine. As long as this here isn't bridging when it's not supposed to, everything will be okay. Trust me. Okay, so let's do our black wire first. Okay, so we'll get our wire strippers. You really do need to have a set of wire strippers to do this. These type are quite nice. There are another set, and that just broke. That is not what we wanted to do. Alright, that's fine. We'll just make it shorter. That didn't really need to be that long in the first place. Alright, so instead of, because these wires are so thin, we can't strip it off and then, yeah. So we'll just take off little bits at a time. Now don't twist that wire yet. If you do, you'll never strip off the next piece. I'm just going to be gentle with it. Now that there is perfect for our run there, and then we want probably a little bit back from that, about there. Just going to have a little gap like that, which we will twist and we'll tin there. And then further up here, we'll start twisting these very, very fine wires together. We'll make a bare ground, which is fine. All of this is a low voltage, and as long as we make sure it's not shorting on anything, it doesn't really need to be insulated. If you're really paranoid, you can hit it with some hot glue when you're done, which we may end up doing in the end anyway, just to make sure everything holds still. These buttons do have a habit of undoing even if you do them up quite tightly. Now that's quite flimsy at the moment because this wire is very, very thin. But you'll notice after we tin it, tinning it's going to add maybe double the volume of wire, of metal that is in this strand, because we're adding all of this solder. So it's going to stiffen right up and be very easy to run where we need to run it. So you see I've just added solder to the end here. I'll just wait for that to cool, which is probably good now. Yeah, and now I've definitely got something to grab onto and twist. And that wire's perfect now. So we'll just give it a little bit more of this with a clean soldering iron. And again, be very quick with this. Take a few passes if you need to. There we go. Oh, I forgot our little buddy in here. There we go. Now, the only downside to doing it this way, by doing it this way I mean fixing the bit that I stuffed up, is now we have less to work with obviously. So it makes everything inside the thing a little bit tighter, but that's fine. We can still get to it quite easily. I mean, I can get to it quite easily. If you don't feel comfortable with that, I would definitely just replace that bit of wire. I'm going to grab my tweezers on this one because I feel that that is going to be the easiest way to do this. There we go. I'm just going to grab our side cutters. And just get rid of that little tail so that it's not floating around. So it does look a little bit messy, but I assure you that all of this is going to work fine. And I think what we might do here is cut that off about there. I'm just going to do the same again. Strip off just little tiny bits until you feel like you've got enough there to play with. So I'll take that last bit off, that bit off, and here's another trick I'll show you. Slide the piece of insulation to the very end and then use it to grab onto and give it all a good twist. Perfect, every single time. The only problem with doing it that way is that if you're only taking a little bit off the end, it generally just flies off. You never really get to it. Like you're not going to have anything there to hold on to. Alrighty. So that's all tinned up, ready to go. Perfect. The heat travels up the bit of wire that you're holding onto if there's no insulation. I don't know, I don't feel my fingers anymore. Alright, so what we're going to do now is just plug this thing into any computer and then start pressing the buttons with Notepad open and see what happens. I'm going to do that off screen. I'm not going to plug it into my streaming PC and do stuff there. I have a test PC over to the side that if it blows out the USB port on that, I don't care. Alright, back in a sec. Back in a sec. It works! So we've plugged all of this into our test computer, detected as a keyboard straight away. There's actually a little LED on the board that I didn't even notice before. It turned on fine. Open up Notepad, and the way that the buttons are working is 1, 2, 3, 4, 6, and then equal sign. So we were a little bit off on the matrix. It doesn't really matter. So the idea behind this is just as long as each button is only hitting one key, and that one key is not already a hotkey within whatever program we're trying to use. And this is more than just OBS. You can use this for anything. I've seen people use this setup for flight simulators, for robotics projects, for even just for video games. I had one friend who put together something like this for World of Warcraft, so they had their own little control pad essentially. Anyway, so what we're going to do first is, I'm most worried about all of these little wires here that are connecting to pads that aren't really pads. So we're going to encase these in some hot glue to give them a little bit more support. And basically just sit there for the 5 minutes it's going to take for the hot glue to go off. And then once that's done, we'll secure it into the bottom half of our enclosure, and then we can close it all up. So this will take just a moment. We'll poke it and burn ourselves just to make sure that it's setting up correctly. There we go. Now, don't do this if you don't have fingers of steel, because it will burn. But what it will also do is make the glue go off quicker. I think I've mentioned this in a previous episode. It's sort of like your finger acts like a heat sink. And it also gives you a chance to really press it down and make sure that everything is making contact with whatever you want it to make contact with. I've just noticed that we missed one of those wires in the process of doing that. So we're really trying to encase this stuff. I think I might just leave it sit there for a little bit. So yeah, once all of this is together, I'm going to quickly connect it up to OBS with the camera off obviously, and set up just a couple of really simple scenes. It'll really just be switching between, you know, the two scenes that I have currently. And yeah, we'll see how that goes. So I'm just going to hit stop for the moment. So there's 2 points that we're going to be gluing on this straight away, and that is our cable entry point. Just a tiny bit on that to begin with so we can still get the cable in, and then a nice big glob that's going to stay hot for a while to stick our PCB to. Now we'll do that in there like that. Pushed hard up against the edge there, so it still closes. And now we may have to three-hand this into position. And all we're really trying to do is just make sure that that circuit board is definitely at the bottom, so that none of the contacts on the back of the case, on the back of the buttons, are touching that circuit board. And that should be strong enough for now. And there we go. That is our control box. I'm just going to knock some screws into that. It does come with a little waterproof seal if you really want to use it. We're not going to bother. Not for what we're doing. So I'm going to, again, cut the camera, we'll get these screws in, we'll get some scenes set up in OBS, we'll give it one really quick test drive, and then that's the end of our video. Alright guys, see you soon. Haha, we're all connected up. It all works. So I have 3 scenes set up at the moment. We have our microscope underneath here. I'll pop a little thing under there just to look at. We've got our overhead camera, as you can see. So at the moment we're on overhead camera, which is going to be this button. We press this one. We switch over to our microscope. So look at that crisp picture. Look at that. And then we've got picture in picture, which is really cool. So now I can say, for example, we'll pop this under, and this way we can sort of have a look at what we're working on, and then at the same time we're able to see where I'm up to on the whole circuit board, and then just switch back. How cool is that? That's pretty cool. That I enjoy that. I hope that you enjoyed this as much as what I did. If you did, please like, subscribe, share it around, send me your firstborn. I don't really care. Whatever the YouTube thing wants at this point, this is just for fun. I enjoy building these things. I'm definitely enjoying building this desk. If literally nobody watches this, so be it. I think at the moment I have 6 subscribers. And total there's been 2 hours worth of viewing on my channel in about 2 weeks, and I'm pretty sure that an hour and a half of that is me. Yeah, alright guys, I'll see you in the next one. Next one we're going to be tackling audio. Look at this, look at it, look at it, how cool is this? Yeah, the next one we're going to be doing our audio, so this stops sounding like I'm talking to you through a telephone from the 90s. And then we might even revisit the lighting, because I'm not 100% satisfied with how it came out. We've got some reflections and stuff going on that are a little bit hard, especially when I work on so many things with screens. Alright guys, we'll see you in the next one.